Hello, everyone. My name is Kong Wang, founder and CEO of Multikernel Technologies. Today, I'm going to introduce you to the multi-kernel architecture, a revolutionary approach that is transforming how we think about the operating system and Linux kernel management. In this video, we will explore why the traditional operating system design are failing to meet the modern tech chain demands, and how our multi-kernel solution provides the performance, isolation, and flexibility that today's applications need. Traditional operating systems, whether monolithic kernels like Linux or microkernels, were designed for a simpler era decades ago. They struggle with three critical challenges. First, scalability bottlenecks. As we move from single CPU to many core processors, traditional kernels become performance bottlenecks. Shared kernel resources create contention, and the one-size-fits-all approach means applications can't be optimized for their specific workloads. Second, noisy neighbor problem. In containers, applications interfere with each other through shared kernel resources. One misbehaving application can degrade performance for everyone else on the system. Third, kernel development complexity. Optimizing Linux kernel requires deep expertise. Custom Linux kernel builds take 30+ minutes. Configuration involves thousands of interdependent options, and updates require reboots with significant downtime. Multi-kernel architecture. Instead of treating your system as a single, monolithic entity, we treat it as a distributed environment. Each CPU core or group of cores runs its own dedicated kernel instance, creating perfect isolation while enabling optimization. Instead of forcing all applications to share one crowded kernel, each application gets its own optimized kernel environment. It's like moving from a shared apartment to having your own house. Complete privacy, no interference, and you can customize everything for your specific needs. The magic happens through our host kernel that acts as a resource coordinator, dynamically allocating CPU cores, memory, and I/O devices to spawn kernel instances. Applications run with near bare metal performance because they have dedicated resources and can use kernel configurations optimized specifically for their workloads. This architecture delivers three game-changing benefits. First, near bare metal performance. By eliminating shared kernel bottlenecks and providing direct I/O access through modern hardware features, applications run at speeds approaching native hardware performance. No more virtualization overhead, no more kernel lock contention. Second, perfect isolation. The noisy neighbor problem disappears completely. Each application runs in its own kernel instance with dedicated CPU cores and memory. One application's behavior cannot affect another. It's kernel-enforced isolation without the overhead of traditional virtual machines. Third, application-specific performance optimization. A database gets a kernel optimized for I/O and memory management. A real-time application gets a kernel with real-time CPU scheduling and latency guarantees. The impact is transformative. Cloud providers can offer differentiated infrastructure services with guaranteed performance isolation. Database companies can ship optimized kernels with their software, eliminating deployment complexity. Real-time systems can achieve microsecond latencies without expensive specialized hardware. Speaking of updates, our architecture enables zero-downtime kernel upgrades. Instead of rebooting entire systems, we can spawn new kernel instances with updated code and seamlessly migrate workloads. Your applications keep running while the underlying kernel is replaced. It's continuous deployment for the most critical system software. The process is elegant. The host kernel spawns a replacement kernel with updated code, gradually transfers resources and state from the old kernel to the new one, and finally retires the old kernel. No single system-wide reboot needed, effectively achieving zero downtime for kernel maintenance. Future of computing is multi-kernel, and that future is available today. Whether you're a cloud provider looking to differentiate your offerings, an enterprise seeking better performance and isolation, or a developer who wants kernel optimization without the complexity, multi-kernel architecture provides the solution. The revolution in operating systems is here. The question isn't whether multi-kernel will transform computing, it's whether you'll be part of leading that transformation. Thank you for your time. Visit our website www.multikernel.io to learn more about multi-kernel architecture and how it can transform your computing infrastructure. And we will open source our solution with the Linux kernel community very soon. Stay tuned.